Hey guys, hey, welcome back. Welcome back to the next installment of Learning Math with Mr. Bauman from Mr. Bauman's Basement. Hope this finds you doing well. Hope this video finds your family doing well on the heels of a hopefully very relaxing and enjoyable Easter with your families. So, our next installment, again brought to you from our basement. Change the location of the camera, my chair a little bit, give you a little bit different backdrop. I got some pictures up on the wall here, some Pope hats from our time in Philadelphia about 5 years ago when we saw the Pope. Pool balls over here, of course, a picture of Jesus. My grandparents, my other set of grandparents. See a wedding picture up here, some handprints from our 3 kids. Just trying to change the setup a little bit. Same math, a little bit different backdrop. Speaking of backdrop, speaking of pictures, first question for you. Let me pull this camera in a little bit. See if you can guess who's in this picture. It's a good looking guy here. Who do you think that is a picture of? Kind of looks familiar, right? If you guessed it's Mr. Bauman, you'd be not correct. That's actually not Mr. Bauman. A lot of people say that I look like this fine young man. This is my grandpa, actually. This picture is probably 80 years old. And growing up, everyone said that I looked a lot like my grandpa when he was in his younger days. Not that I'm in my younger days, but anyways, he was a Greyhound bus driver. And apparently in his free time, I'm trying to get not glare on this picture. Apparently in his free time, he really loved to box. I don't box, but my grandpa did. I thought it was a pretty cool picture. I just wanted to show you. Kind of looks like me. If I take my glasses off, and imagine me without a mustache. I could see that might mistake my grandpa for me, but anyways, pretty cool picture. Let's get into the math. Here's what I'd like to do today. We're going to finish up chapter 10. And then moving forward after this section, as I mentioned in the Google Doc, I'd really like to spend these last few weeks really kind of retouching or re-examining those major players, those major standards from 7th grade that really in particular are going to be seen again and used, kind of built upon in 8th grade as we kind of roll through 8th grade pre-algebra, 8th grade algebra skills. So I'm going to really try to re-examine those major players from 7th grade math that are going to be just the foundational skills that you're going to need to be just rock solid as you kind of transition into 8th grade here in the next couple of weeks. So we kind of bridge that gap between 7th grade math and 8th grade math. But first things first, today in this video, we're going to finish chapter 10, which is all about probability and statistics. Really like this lesson, and I give you a chance to write this objective. I'm kind of joining about 2 sections from the textbook into one, but I really like this section. I love studying numbers, analyzing numbers. What do the numbers mean, and how can we utilize those numbers and those models in real life? So by the end of today's lesson, you're going to be able to calculate 3 of the first ones are called measures of center, which I know you've seen in younger grades, mean, median, and mode. But then some new material here in 7th grade, we're going to look at called measures of spread. In other words, how spread out are these numbers in this data set. And one of the things we're going to look at is called the interquartile range. You can get this in your notebook. And also what's called a box and whisker plot. A box and whisker plot. So if you need to pause the video, go ahead and do so to finish getting this objective. If you need to go run and get your notebook, a pencil, you're also going to need a calculator today as well. If by chance your calculator is still sitting in your locker at school, and I know you haven't been back at school, neither is this guy, you can just use your calculator on your Chromebook. All right, so pause the video if you need to, finish getting the title and the objective, and we're going to jump right into it. So I've got my supplies, got my whiteboard, marker, the magical eraser. Obviously got the camera, got my chairs, got my nice backdrop here, and of course, no math lesson is complete without a nice Warm cup of joe. Ah, that's good. That's good. What do you think of the mustache, huh? Pretty nice. This thing's been growing for 31 days. I think we're on day 31 at home. But anyways, let's jump right into it. All right, so finish up our study of statistics here. We're going to look at the first three things we're going to look at are called measures of center. In other words, how closely grouped together are numbers in a data set, and how close are those numbers to the center of the data set. So these first three that we're going to look at are called measures of center. So let's suppose you had 10 classmates that were surveyed, or they were asked a question, and the question was, how many times did you turn on Netflix? Now let's do Disney Plus. So 10 classmates were surveyed and asked how often or how many times did you turn on Disney Plus in a week? All right, so you can get this survey question into your notes. How many times did you turn on Disney Plus in 1 week? Okay, just 10 random kids from your class were asked. And again, if you need to pause the video anytime I hold up my board, anything I write on the board, if you could get in your notes, it's going to be important stuff. So 10 kids were asked, and here's the results. And I'm going to put them in what's called a set. It uses a brace, and I'll show you this brace here in a second. This is starting to get into a little bit of 8th grade algebra. So the 10 kids were asked, and here come the results. I'm not putting them in order, and that's one of the things that I'm asking you to do today, is put these numbers in numerical order. Trying to squeeze them in here. So here's our 10 answers. So kid number 1 says, well, I turned on Disney Plus 9 times last week. The next kid says, well, I only turned it on once. The third kid said 13 times. Fourth kid turned it on 10 times, so on and so forth. That's 15, 14, 10, 12. This kid might have a little bit of a problem. 37 times this kid turned on Disney Plus in 1 week. 37, and this is 11. Kind of had to squeeze it in there at the end. That's an 11. 9, 1, 13, 10, 15, 14, 10, 12, 37, 11. I think that's 10 kids. Yes. Okay. So there's our 10 answers to this survey question. So my question is, if that's the case, what are our measures of center? How closely clumped together are the numbers in this data set? Are they pretty spread out? Are they pretty clumped together? Are they evenly distributed? That's what we're going to model and calculate here today. So first things first, let's look at these measures of center. And I know you've looked at these before. They're called mean, median, and mode. The measures of center, mean, median, and mode. And again, I know you looked at these probably starting in like 4th, 5th grade would be my guess. Mean, median, and mode. In order to do one of these, we definitely have to put these numbers in numerical order. From left to right, let's rewrite these from smallest to biggest. All right, I'm going to do mine and see if your list is the same as mine. Looks like 10 happened twice. Again, this is called a set. This symbol here is called a brace. It's called called a brace. It's not a parenthesis, it's a brace. So it's kind of like squiggly, and I'll teach you how to draw that next year when we talk more about sets. This is a brace. You put a brace at the beginning, and you put a brace at the end. And I listed them in numerical order. So let's try to calculate these. A few of them are real fast. One of them takes a little bit more time, and a calculator really comes in handy. Let's talk about the easiest one, mode. This is just a review from younger grades. Mode is the number that occurs most often. Obviously that's 10. 10 happened twice, no other number repeated, so the mode is 10. The median. How do you calculate the median? That's right, it's the number in the middle. Just like the median on a road is right smack in the middle, a median in a set of numbers is right smack in the middle. That's why we numbered them in numerical order. The problem is I have an even number of numbers. How do we calculate the median if that's the case? That's right, you take the middle two, add them together, and divide by 2. In other words, you're calculating the mean of the middle two numbers. So what's it mean to be a mean? It's the average. So in this case, if I look at the middle, that's going to be between the 5th and the 6th number. So that's 11 and 12 are right smack in the middle of mine. So the median is the middle of these two numbers. You can take out a calculator if you want to, but you should be able to do that mentally. What's the number that's right in between 11 and 12? That's right, it's 11.5. So the median for ours is 11.5. What if there had been an odd number? What if I only asked 9 kids? Then the median is the middle number. Okay? But we had an even number, so we had to do a little calculation here right in the middle, and we got 11.5. The mean, as I mentioned, the mean is the average. Take all the numbers, add them all up, and then divide by the number of numbers. Go ahead and pause your video. You go ahead and do yours on your calculator, and I'm going to do mine. All right, unpause. I got 132 when I added all these up, and then divide by 10. I got 13.2. That's the mean of this data. The first question on your homework on the Google Doc tonight is exactly this. What are the mean, median, and mode? Totally review from younger grades, but I know you guys can do it. A calculator will probably come in handy on question number 1 on your Google Doc. Alright, so this tells us a little bit of information. On average, the average number of times that Disney Plus was turned on was 13.2. Right in the middle is 11.5, so these numbers aren't too far off, and then the one that happened most often was 10. These are relatively centered. They're all kind of clumped together, all kind of grouped together. They're all kind of leaning towards the fact that most kids watch somewhere around 12 or turn Disney Plus on somewhere between like 10 and 13 times per week. All right, those are the measures of center. Let's move on to some newer stuff. How about the measures of spread? If you looked at the Google Doc, you probably noticed this vocab word. The measures of spread. It means exactly what it says. We're measuring how spread apart are these numbers. This kid only turned on Disney Plus 1 time, while this kid's got a little bit of an issue. He or she turned it on 37 times last week. What's the spread between these two numbers? What's the difference between those two numbers? That's some of the measurements that we're going to look at now. Let's talk about one of the more basic ones, called the range. The range is literally the difference between the high, which in math we call that the maximum. So I want you to start using the word maximum. Sometimes we abbreviate it just to the max. Is the difference between the high and the low. And the low in math we call the minimum. So I'll give you a chance to get this definition. The range is just the difference, so we're going to be subtracting, between the high and the low. In other words, the difference between the max and the min. On your homework assignment, I'm going to be using the words max and min. It's the difference between the high and the low. That one you should be able to do mentally. The difference between the high and the low is 37 minus 1. So the range is 36. In other words, there's a 36 unit difference between the kid that turns Disney Plus on 37 times and the kid that only turned it on once. That's a relatively high range. But that's considering all of the data points. What if I really wanted to focus on the majority of times that Disney Plus was turned on? In other words, what's the highest concentration? What's the highest kind of bulk, the highest grouping of data points in this set? In other words, if I were to really kind of narrow the focus like a camera, if you kind of zoom in on the ones that occurred most often, how big is that subset? How big is that group? And that's what we call the interquartile range. Give me a chance to erase here, and I accidentally erased my data points. Let me rewrite those. Alright, so the next vocab word is the interquartile range. You really only have to write it once because I'm going to start abbreviating it. The IQR. The IQR. Interquartile range. Let me go ahead and get you this definition. This measures where the bulk or majority of the data points lie. You need to pause the video. I'm going to try to keep moving along. So if you need to pause the video to get this definition in, it measures where the bulk of the majority of the data points lie. Kind of jumping the gun, the assignment tonight, you're going to be looking at free throws made in a free throw contest. So you're going to be looking tonight, where is the bulk of the majority of the numbers of free throws made kind of fall on this graph. For ours today, it's how many times was Disney Plus turned on, where the majority of the points lie on this graph. If you just kind of study the numbers, most of them are around this like 10 to 13, 10 to 14. The majority of them are right around there. Another way to look at this, if all the numbers in your set are considered 100%, so it's like the entire set or range is one whole set, we're kind of looking for the interquartile range. The IQR kind of measures what we call the middle 50. It measures the middle 50, and by 50 I mean 50%. If you kind of think of like a football field, from goal line to goal line, that's 100 yards, right? So we could split it in half and we can go 50-50. But if we want the middle 50 from the 50-yard line, we'd go 25 yards this way and 25 yards this way. This middle part would be considered the middle 50. Then there's 25 yards here, 25 yards here. So we kind of split the football field into quadrants. And you notice I'm trying to read backwards here. QUAR means 4, right? If this is Mrs. Trumbull's class looking at like different stems, this would be 4. So we've split the football field into 4 parts. The 2 parts that we're considering here are the middle 50 yards. 25 yards here, 25 yards here, for a total of 100. We're looking at the middle 50. And that's where these middle numbers are kind of all grouped into this middle one. We're going to be talking about what is this over here and what is this over here in just a second. But for now, the IQR is this middle 50. I hope that football analogy kind of helps you kind of visualize what this model is going to look like. All right, enough of definitions. Let's start doing some calculations. And by the way, before we jump into that, we're going to be talking about, kind of going back to the football field, we're going to be talking about a model. And I'm going to draw a real quick one here for you. We're going to model all this data using what's called a box and whisker plot. Kind of a fun name. It measures the spread, so how far spread apart are these middle 50, and then how far spread apart are these endpoints, are the max and the min spread out. And you can kind of tell now why they call it a box and whisker plot. Here's the box. And these two lines coming out of the box, these are called the whiskers. Whiskers is kind of like like a cat whisker. Meow, to make this box and whisker plot, which I'm going to show you towards the end of the video, we're going to need some other measurements. Yeah, I'm not kidding around. This really is called a box and whisker plot. Meow, they really do call it that. And it's, some would consider it the perfect name for a box and whisker plot because of these lines coming out of the box, which we call the whiskers. Meow, let's go ahead and take a look to see how we go about coming up with those different values for this box and whiskers plot. All right, so I have my data set, and I want to calculate the IQR, the inner quartile range. How do we do that? We need to split our set, our data set, into two parts, what we call lower and an upper. The lower half and the upper half. So obviously we have 10 numbers in our data set. So the lower 5, I'm going to put parentheses around them. Kind of like that. And then the upper 5, I'm going to put parentheses around those. Once I have parentheses around the lower half and the upper half, let's find the median of these 5 numbers. Find the median of these 5 numbers. Since I have an odd number, I only have 5 numbers in this set of parentheses here, the median is the middle number. So that number right there, this is the median of the lower half, which we're going to start calling the lower quartile. This is the median, so 10 is the median of the lower half, which we call the lower quartile. And this number we're going to call Q1 for quartile 1. So we're just abbreviating the word quartile with capital Q. You can probably guess, to get the other median, now we have to take the median of this small set of numbers. So there's only 5 numbers, So the median is the middle one, which obviously is 14. We're going to call this Q3. This is the median of the upper half of numbers. So we're going to call this the upper quartile. I'll give you a chance to write that down. Q3 is the number 14 because it's in the middle of the second half. It's the median, the middle of the upper half of the set of numbers. So we're going to start calling that the upper quartile. All right, so we still haven't calculated the IQR. You might be wondering, well, okay, I get it. That's the middle of the lower half, and it's the middle of the upper half. Now what do I do? So the IQR, once you have those two numbers, the IQR, this is a big one. You might want to put a star next to this. This is another question on your Google Doc. The IQR is Q3 minus Q1. So in our case, that's 14 minus 10. So our IQR our interquartile range is 4. What does that mean? Well, when we do our box and whisker plot, when we draw our box, our middle 50, remember I talked about where is the highest concentration, where the bulk, where the majority of the values kind of concentrated? The majority are somewhere between 14 and 10, which kind of makes sense. If you look at our data, the biggest chunk of our data set is right there. It's somewhere between 10 and 14. So our interquartile range, so our inner range, our middle 50, is only 4 units big. In other words, we could make the statement most kids turned on Disney Plus sometime or somewhere between 10 and 14 times. Does that mean every kid turned it on between 10 and 14 times? No, but the majority or the bulk of the kids turned on Disney Plus somewhere between 10 and 14 times. The IQR is only 4 units big. All right, so that is IQR, one of the 7th grade standards. No math lesson is complete. All right, we're going to get into the last one, the last measure of spread, and then we're finally going to take a look at that box and whiskers plot that I've been promising you. Yeah, we'll get to it here in just a few minutes. All right, measure of spread. The last measure of spread is called mean absolute deviation. And instead of writing that out every time, we're just going to abbreviate it MAD. M-A-D. Mean absolute deviation. If you were in Mrs. Trumbull's class and she asked, what is the word deviate? So that's the root of deviation. To deviate means to kind of stray away from the center or the expected or the normal. How far did each of these points kind of stray away from what you expected or what you consider normal times of Disney Plus being turned on? The normal is somewhere around here. How far on average is each of these points from what you expect to happen, or the normal number, the median or mean number of times that this happens? So that's what the word deviate means. How far away from what you expect to happen, or the center, is each of these values? And then mean obviously means, again, the average. So on average, how far away are each of these numbers from the center? And we'll talk about why it's called absolute here in just a minute. All right, let me switch papers here. So here's kind of the official definition of the mean absolute deviation. You might want to put a star next to this definition. We're going to find the average. That's why they call it the mean absolute deviation. The average distance each point is away from the mean. We're going to find the average distance. This is kind of a big word, or not big word, but like key player. Oop. Find the average distance each point is away from the mean. Give you a chance to pause the video because I'm going to erase this here. So pause the video if you need to get this definition down. And the average distance that each point is away from the mean. So, first of all, let's remind ourselves from the very beginning of this video, our mean was 13.2. If you need to flip back in your notes, you should have this somewhere towards the beginning. Our mean was 13.2. That's an important number that we're going to consider here in just a second. But to show this, I think it might be helpful to do like a big number line. At the end of this number line, let's put the number 1, because that was the smallest number in our set. And at the other end, let's put the number 37, because that was the largest number in our set. So here in the middle, this is 36 long, so half of that's 18. Half of that's 18, so plus 1. So let's call it, this is let's put 19 right here in the middle. So we get some perspective here. So 10 is about right there. I'm just trying to kind of build up my my number line. I really don't need to put anything over here because the only number that was bigger than 19 was 37, and I already have that one. So I think that's enough for now. You could put like 1 unit to the left and 3 or 4 units to the right, because most of our interquartile range, most of the points were in this group or this general area right here. So let's do what's called a dot plot. You did this as a little kid. Let's do a dot plot. Let's put a dot above each of the numbers that's in this data set. So there's one kid that said 1, one kid that said 9, 2 kids said 10, one said 11, one said 12, one said 13, one said 14, one said 15, and then one kid said 37. So our dot plot kind of looks like that. And there you can kind of visually see that the biggest bulk of students answered somewhere between 9 and 15. So how do we calculate the MAD, the mean absolute deviation? Hang with me here. This gets a little tricky. I'm going to do my best with the limited resources that I have. How do I find the mean absolute deviation? I want to figure out how far away is each of these points from this number. So 13.2, I'm going to put a big line right where 13.2 is on my dot plot. If you want to go ahead and label yours, I put a big line straight down where 13.2, that's my mean, straight down, that's where my mean is. My question is to figure out this, how far away is each of these points from 13.2? So if I want to figure out distance from 13.2, all I need to do is subtract. So let's start with I'm going to create some space over here. What if I did 13.2 minus this first one? So how far away is this point from 13.2? All you have to do is take 13.2 minus 1. And obviously that's 12.2. That's my first distance. Let's do the next one. This is 9. How far away is 9 from 13.2? Again, you just have to subtract. That's 13.2 minus 9. That's 4.2. I'm going to keep doing that how many times? That's right, 8 more times for a total of 10. So you should have 10 subtraction problems here. This is very similar to what you're going to be doing on the Google Doc today. So this part of the video, you need to come back and revisit. You need to re-watch this part of the video because this gets a little tricky. Now let's do the next one. I'm going to figure out how far away is this point from 13.2. But I need to do that one twice because 10 happened twice. If you want to go and pause the video now that you kind of see the pattern happening here, I'm going to have 10 subtraction problems here. The last 3 get a little tricky, and I'll come back to the video when I get to those. So go ahead and pause your video right now if you'd like to. I'm going to finish up mine, you finish up yours. All right, unpause. So far I have 1, 2, 3, 4, 5, 6, 7. And here's the differences or the distances that I got from each of those. I didn't do the last 3 because I want to walk through these last 3 together. So I'm to this point right here, which is 14. How far away is 14 from 13.2? So if I continue the pattern, I'm trying to figure out 13.2 minus 14. What kind of number are we going to get? That's right, we're going to get negative. But you can't have negative distance. So how can we make a negative number a positive number? That's right, use absolute value. That's why they call it mean absolute deviation. Because if you get a negative number here, all you have to do, remember the absolute value bars? You just have to take the absolute value of this difference. So this is going to be positive 0.8. That's how far away 14 is from 13.2. Absolute value of that is 0.8. So you can do the last few. I'm going to do mine here real fast. Get 1.8 and 23.8. So there's all 10 distances, but now we need to figure out the average. So here's where a calculator really comes in handy. At this point you're going to add up all 10 of these numbers. Go ahead and pause the video. It's going to take a few seconds to type in all these numbers. Add up all of these distances. Go ahead and do that now. Okay, you got that number? Now divide by the number of numbers, because it's a mean. I got 52.8. I'm going to divide by 10. So my mean absolute deviation is 5.28. Now the big question is, what does that mean? On average, the average distance between each of these points and the mean, 13.2, the average distance is 5.28. Does that mean every single one of these points is 5.28 away from the median or mean? No, not a chance. But on average, that's how far away it is. So it's telling us how closely clumped together are most of the data points, or how far apart are they spread. That's really what we're looking at. The statistics is all about figuring out patterns and trends, and how closely are things clumped together, or how much can you spread them out over time. All right. So it all leads up to, how are we going to model this the best way we can? Meow, we could make a dot plot, which we've already done, but I don't think a dot plot is probably the best way to approach this. So we're gonna use a different model, and some would consider it the perfect model for this data. And again, it's called a box and whisker plot. Whiskers like a cat. I'm not kidding around. This really is called a box and whiskers plot. Meow, what would it look like? Sorry, Lily, for all the cat jokes. But what would this look like? It truly is a box with whiskers. So we're going to start with just a blank space here. I need to erase a little bit more. We're going to start with 2 points. Our min and our max. So let's go ahead and label those. We got 1 and 37. Let's label this min for minimum and max for maximum. Again, another question on your Google Doc. I'm going to ask you to label a box and whiskers plot. And again, just so we can kind of gauge like distances here, we know 19 is going to be about in the middle. I'm going to do it real light and real small. I know 19 is about in the middle. Here's the next thing we want to put on our box and whiskers plot. We need the median. So flip back in your notes. What was the median of our data set? That's right. Our median was 11.5. So I'm going to put a dot at 11.5. On your box and whiskers plot tonight, you're going to have to label your median. Ours was 11.5. And through that point, I'm going to draw a line. And I labeled it median. The next 2 points you need to put onto your box and whiskers plot are your Q1 and Q3. Flip back in your notes, pause the video, flip back in your notes. What was Q1? What was Q3? Our Q1 was 10. So it's pretty close to 11.5. And our Q3 was 14. So it's a little bit further away. Here's Q1, here's Q3. Draw lines through each of those. So I have a min, a max, my median, Q1 and Q3. What do you think you're going to do now? That's right, you're going to box in, you're going to connect these lines. There's your box. There's the box for your box and whiskers plot. Meow, the only thing you need to do now is draw in your whiskers. Meow, that's the fun part. And there is your box and whiskers plot. What does this tell us? What does this mean? If I showed this to my wife and I said, hey, what do you think this graph means? What do you think this plot means? she'd be able to tell me, without even knowing what we're measuring here, she should be able to tell me that the majority of the numbers fall between 10 and 14. Then she could probably be able to tell me that for whatever reason this is a really low number, kind of far away from 10. And then the one that probably is going to catch her eye the most is, why is 37 way out here? It's not anywhere even close to the majority, the middle 50%. It's not even close to this middle 50 percentile. Which leads to the last vocab. Any numbers that are kind of floating off in no man's land in either direction, that really are not close to the rest of them, they're called outliers. They're kind of doing their own thing, sailing their own ship. For whatever reason, this kid only turned on Disney Plus once. And the one that really intrigues me is, why is this kid turning on Disney Plus 37 times when the majority of the kids are somewhere between 10 and 14? These are called outliers. They can sometimes kind of skew the data. They kind of mess with the data a little bit, either taking it too far up or too far down. What you're going to be doing tonight, last question, what you're going to be doing tonight is, what would happen if this kid, instead of 37, what if he or she only did it like 20? What if he or she only turned on Disney Plus 20 times? What would happen to this outlier? What would happen to the size of this box? Would the box then get wider? Would it get more narrow, or would it stay the same size? What if this kid, instead of doing one time, what if this kid turned on Disney Plus 7 times? Would this still be considered an outlier? What would happen to the size of this whisker? What would happen to the size of this box? So interesting questions arise when you start to mess with the outliers. How does that change the look of this box and whiskers plot? That's what I'm asking you to do on your last question on the Google Doc. So at that point, we are done with this section. We are done with Chapter 10. And just like that, the stamp of approval is on the 7th grade standards. We are officially done with all of the 7th grade standards. Congratulations. Job well done. And we're almost there. If you have questions at any point, please email me with your questions. I tried to go very methodically through the Google Doc. It very much aligns with the notes that we took here today. So feel free to replay the parts of this video to get you kind of caught up to speed on any of those particular questions. As always, I hope you're doing well. I hope your families are doing well. Thanks so much for watching this video. I hope you're still awake. Maybe the magical eraser or the magical mustache help keep you awake, or the really bad cat jokes. My apologies again, Lily, for dropping all those cat jokes. I know Meow, sometimes they get a little redundant, but you know me, Lily, and the bad jokes just they're infinite, really. They're really quite infinite. So Meow, I do apologize for that. But have a great, all kidding around aside, I hope you guys have a wonderful day, and be kind to one another. I know I say this at the end of every video, but it's true. I hope you're being kind to one another. Be patient with one another. I think we all need a tremendous amount of patience. And above all, please pray. Please continue to pray. Pray for one another. Pray for the safety and well-being of everyone out there. So it's great seeing you guys. I can't wait to see you again in person, hopefully much sooner than later. And I hope you have a wonderful day. Email me with questions, and we'll catch you guys soon. All right, take care.